Now we're looking at a question here talking about seabed. So it says Lana needs to put mesh around 2 seabeds, right? Mesh around 2 seabeds to protect her seedlings. So altogether she used 60, right, meters to mesh that around. All right. On one of the seabeds, one of the seabed is a rectangle, the other one is a square, as we could see here, as shown in the diagram. So we're going to get some specific details now relating to the question. The width of the rectangular seabed is x, and we're seeing that they gave us this, so we're seeing this right here. And then now it says the length is 3 times the width. So that means I'm going to just represent this as 3x. Also, we were told that the square, we're told now that the length of a side of the square is y, and that is actually there. Using the information given, derive a simplified expression for y. All right. So what we want to do is that the idea about this is that this is also 3x and this is x. This is y, this is y, this is y. So what we're saying, they want us to represent y, but what we do have is that if we should add up this perimeter of the 2 shapes, right, it's going to equal to 60, right? So what we could do here is that if I add up the one for the rectangle and subtract it from 60, I'm going to end up getting the one for the square. For example, I'm saying this. We could just look at that. 4y, because if I add y plus y plus y plus y, 4y is equal to 60 minus whatever we have for the perimeter for the rectangle, which is 3x plus x plus 3x plus x, right? So basically, I'm just saying 4y is equal to 60 minus, this is 6, this is 8x. And then now y alone, because we were told to find y, I'm dividing by 4, y is going to equal to 15 minus 2x. So that is the value of y right there in terms of x. So y is equal to 15 minus 2x. All right. So we want to make sure that we have this down. The length y is y is equal to 15 minus 2x. And it simply means that at any given time, I can substitute 15 minus 2x for y. All right. Let us jump on to the next question. The area of the rectangle seabed is equal to the area of the area of the rectangle seabed is equal to the area of the square, right? All right, good. So we're getting that. So the area of that is equal to the area of that. So it says use this information, use that information and your thing to write a quadratic equation in terms of x to show this. All right. All right. So we're looking at the fact that the area of the rectangle seabed is equal to the area of the square. All right. So both of them are equal. So what we can do then, we can put all this together, right? So let's take a look at this. Take a look at this. So what we have here is, remember now that 3x times x. So this is the rectangle one right here, which is 3x, and this is x. So length times width is equal to, remember this is 15 minus 2x. All right, 15 minus 2x, right? So basically then, this is 15 minus 2x all squared. So if you break down this now, all we got to do is to simplify this. So this is 3x squared. And let us say we put this here. I'm going to just put this right here, 15 minus 2x. I'm going to multiply this by 15 minus 2x again. And if we should distribute, 15 times 15 is 225. 15 times 2x is going to give us negative 30x. Negative 2x times 15, negative 30x again. And then negative 2x times negative 2x is positive 4x to the second. So on this side, this is what I have when I simplify this idea. I have 4x squared minus 60x plus 225. That's what I have. Now, in this case, we want to represent the idea such that it shows like this. So what we're going to do is that we're going to subtract 3x squared from both sides. So we get a 0 on this side. 3x, so 4x squared minus 3x squared is going to give us x squared minus 60x plus 225. And there it is, we would have shown getting back that as what they gave us. So this is us representing, and we got that, right? That means everything that we have done so far in relation to this is actually accurate. Now they're asking us to solve this, right? So solving this, when I'm checking this out, it cannot be factorized, right? So what we're gonna have to do is that we wanna list what is A, B is negative 60, and C is 225. We're gonna set up our quadratic formula where X is equal to minus B plus or minus the square root of B squared minus 4AC. All of that must be over 2 times A. So let's go for it. Minus B, and B is negative 60. So we have a minus there. Plus or minus the square root of negative 60 square minus 4 times A times C. And all of this must be over 2 times A. A is 1. Let's go again. When the two negatives clash out there, we're actually looking at positive 60 plus or minus the square root of 3,600 here. And this is minus 900 here. All over 2. Let's keep going. We're looking at 60 plus or minus the square root of, this is 2,700 all over 2. All right, let me double check that number there. 36 minus, yeah, it was good. 2007. All right, so we're almost there. We're almost finding X now. So X, so let us find the square root of 2,700. All right, so 51.96. So what we actually have here is that 60 plus or minus 51.96 over 2. So let's work it out. So X is equal to 60 plus 51.96 over 2. So let's work that out. 60 plus 51.96, divide that by 2. We're getting about 55.98. All right, so that's one value. And in the second instance, X is equal to 60 minus 51.96 over 2. 60 minus 51.96. So we have 8.04 over 2. So I'm getting X to be 4.02. Okay. All right. So I have two values for X here. I'm just going to highlight them. I have this as a value for X as well as that as a value for X. All right. So we have two values for X right there. Now, let's see what the next question says. The question says, calculate the area of the two seabeds. All right, so we want to find the area of the two seabeds, all right? The area of the two seabeds. Now we're going to have to check out the sides to see if they make sense in context. So let's go back, right? All right, let's see. Let's see if the sides would make sense, right? So when we are here, take a look at what this is. Remember that y is equal to 15 minus 2x. Now, if I go ahead and plug in the 55 point, what we have here, 55.98. If I put 55.98 here, take a look to find what is y. So 15 minus 2 times 55.98. You're going to realize that there is an issue here, right? So 15 minus 2 times 55.98. You're going to get a negative number, right? This is negative 96.96. And this cannot be, right? So we're going to have to ignore one of our quadratic answers in terms of to put this in a real world context right now. So the answer were 55.96. It is theoretically correct, but for the situation, it cannot be because we'd have a negative side and we cannot measure and get a negative length, all right? So because of that fact, we're going to have to we can only use the 4.02 to work with here. So we're going to use the 4.02 to work out the area. But as you could see, so let's go back. So 4.02 is good. So take a look. So we're looking at having, remember, I know, if I should go for the ideas that we got, let me show us the ideas that we got right here. The ideas that we got right here, this idea is actually representing the area. This idea, because we have area equal area here, and we broke this down, right down. So whichever way you want to do it and put it together, you could do it like this. Take a look. 3x squared was for the rectangle, right? And for the square, it was 15 minus 2x squared. So if we substitute our values there, right? So all we got to do is to substitute x equal to 4.02, because we just realized that if we use the 55.98, we'll get a negative side for the square, and that can't work. So right here, we're just substituting. We're just going to add these up. 4.02, we square that. We're going to add this up, and it's going to give us the area of the two seabeds. So let us just go ahead and do that, right? Let's just go ahead and do that. So 4.02 squared, that's 16 point something times 3. I'm getting 48.48. All right. So that's one there. 15. If you want to square this, what if you want to work one more step? You could. That's a negative. You could work out what is inside the parentheses there. So 4.02 times 2. Yeah. So, all right. So this is actually, when you work out this, you're actually going to get 6.96 right here, right? This is actually 6.96 if you square it. So let us square 6.96. All right, we're getting back the same thing. But remember that we were told that the area was the same, you know. All right, so we round this off. But at the same time, we're still getting a 48.44. So basically, we could have doubled this, and we would have been good based on the context that the two areas are the same. We find one, we could double it. Remember that we round off these figures here. So when you round them off, you're going to shave off a little bit. But we could add these, and we still go 48.48 plus 48.44, and we get somewhere 96.92. We could round this off to approximately 97, right? So we're looking at about 97 units square right there, depending on whatever units that were used there in the question. Let me look if it was meters. Yeah, it was meters. So we could round it off to 97 meters, square meters right there. So that's